So the OSI model layers, basically what we have here is, as we mentioned, it allows devices to intercommunicate. So what you see here is one device on the left-hand side under the title needs to intercommunicate with the other device. Maybe it's requesting a web service, a file and print service, maybe it's printing, whatever, there's communication. So the one starts, it goes through the different layers, and on the right-hand side of the table, it shows you what the data unit is called. Data, and then we get to segment, packet, frame, and then once we get to the physical layer, it becomes bits. It goes across the wire, that's our physical media, goes up the next one, and then basically it just gets deconstructed or reconstructed. So as the message goes down, it kind of gets deconstructed into the appropriate layer. As it hits the other side, it gets reconstructed.
Well, and the terms they use, I didn't want to go into too much detail as I was building these slides because we want to give people the right amount of information for this exam and to have the information they're going to need to do the job, but not necessarily so much information like, you know what, after 3 slides, I don't need to watch this anymore, I'm going home. The protocol data units on the right, you're not going to hear that term very often, but what happens as the data moves from top to bottom, you start with a piece of data at the application layer that is actually added to as you go from top to bottom. So it's either added to or in some cases broken apart. I start with a given amount of data, the next layer adds headers to that. The next layer breaks it into smaller consumable pieces to actually put on the wire and may add more information to those smaller pieces. So we're not going to dive into the actual technical details of what happens to each layer, but that's what this is describing, is that information is being, the data itself, your actual chunk of data is being modified, manipulated, broken apart, tagged, and built in a way that when it gets to the physical layer, those bits can be sent across and then successfully reassembled up the stack on the other side.
So now let's go ahead and start taking a look at the different layers. Layer 1, physical layer, defines the physical and electrical media for data transfer. Whether this is wired or wireless, they need standards of some kind. You need to know how to build the media. For wireless, what signal strength do I use? What signal channel do I use? For wired, what type of wires and cabling do I use? What type of jacks do I use? Physical layer components include cables, jacks, patch panels, punch blocks, hubs, and mouths. Physical layer concepts, and we've talked about some of this already, topologies. So what the network physically looks like. Analog versus digital encoding. When we think of analog, think of the old style analog clock. So it can be any of time versus a digital. Digital clock is discrete. So it's either 10:05 and then it becomes 10:06. Maybe your digital clock doesn't have seconds on it. So let's take seconds away. So your clock is 10:05 and then it flips over and becomes 10:06. The gradation displayed to you is just, it's one and then it's the next. For analog, so you have the analog, you have the hands on the clock, it can be any value within that system. So think of it that way, hands on a clock or digital media. Bit synchronization, baseband versus broadband, multiplexing and serial data transfer. We'll get into these topics more later. And the unit of measurements at this level is bits. So Ethernet standards. We've talked about the Ethernet. Ethernet standards is basically the standard for communication over networks. This has a frame type, so how data is packaged and sent over the wire. It has a physical media that can be described. As Christopher mentioned earlier, 802 is the Ethernet standard. Well, .3, .11 are the different standards of Ethernet that describe frame type, physical characteristics, electrical characteristics. All those are described in those standards. Define physical and data link layers, so the first 2 layers. 100 base T is an example of an Ethernet standard. And to kind of break that down, the 100 stands for 100 megabit. The base is for baseband versus broadband. And T is for twisted pair cabling.
Which we'll look at later as well.
Yes. Baseband refers to the fact that the networks use digital signaling over a single frequency. Broadband systems use analog signaling over a range of frequencies, enabling multiple channels over the same physical medium. So again, if we think of digital and analog, not to hammer this, but I think this is kind of an important concept to understand. For digital, if you're looking at here, digital is discrete. So with digital, the data is zeros and ones. It's here or it's here. So it's very discrete. For analog, it can be anywhere within this range. So anywhere within this range up here or down here can be analog. With an analog channel, devices can speak anywhere within this channel. For digital, you have these two areas. It can be here or it can be here. So again, something to think about, hands of a clock versus digital clocks.